So just continuing section 3 with slope intercept form. Standardized tests love to throw questions at you involving slope intercept form. They disguise them a little bit. They'll do something like this. Which of the following is an equation in slope intercept form for the line shown? And then here's the graph. Okay? Now, if you look at the answer choices, since we're pretending this is a standardized test, you're going to have 4 or 5 answer choices sitting over here. On those tests, they're going to give you all answers that seem like they could be right, especially if you forget one little rule or something like that. So one tiny mistake, and probably that answer is going to be sitting over there. And they know what mistakes you're most likely to make, so they know what mistakes to show in their answers. It's very likely that everybody, or every one of those answers could be given as an answer by somebody if they forget something. So my advice to you is this. Start general, and then get specific if you need to. So what's the first thing you notice about this graph? I'm not looking at the answers at all. What's the first thing you notice about the graph? Okay, you see a y-intercept of 1. You're actually more specific than I'm trying to get you to be. It's going down from left to right, which means that it has a negative slope. So I can come over here to my answer choices and look to see if there's any positive slope sitting here. And if there is, I can get rid of that answer choice immediately. Okay? So do I have any answer choices that have a positive slope? No. All right, so I can't use that one. But that's a good place to start, because a lot of times they'll give you one that has a positive slope, and you can just eliminate it. All right? That makes your guessing, if in the end you have to guess, your probability of guessing the question correctly increases anytime you can obviously eliminate an answer choice. All right, so the other one we saw was that the y-intercept is 1. Okay? Now, if you understand slope-intercept form, then you know that that 1 is going to show up in the equation somewhere. Where does it show up? At the end, the B part, the part that's by itself. So is A a possible answer at this point? Yes. Is B a possible answer at this point? No. So it can't be B. Is C a possible answer? Yes. Is D a possible answer? No. Okay? Notice that I haven't even done any math here. It's a math problem, but there's no math to do. It's just looking and answering. All right? Now, the last thing that we have to look at is, I have A and C here. What's the difference between these two? So the slope for one of them is 4, and the slope for the other is 1/4. What's the difference between a slope of 4 and a slope of 1/4? So if I'm just looking at the graph and describing its steepness, which one's steeper, 4 or 1/4? 1/4. So if I'm looking at this graph, do I see a steep line or a shallow line? Shallow. So I'm kind of leaning towards the answer being C, negative 1/4 x plus 1. Okay? That is the answer. But since this is a standardized test and we want to make sure that we're right, it's very easy to check with rise over run. From here, I can go to here. So down 1, right 4. Anytime I go down, that's negative. And then right 4, so it's a negative 1/4. The answer is C. That's one way you can do a problem like this. Now, it took me like 3 minutes to explain all that. Would it take you 3 minutes to go through that process here? No, definitely not. Okay? In fact, I have one more problem for you, and I want to time you. See how long it takes. I will give you less than 1 minute. 45 seconds. Go. And when you have your answer, go ahead and raise your hand. That was like 30 seconds. Not too bad, okay? Which of the following equations in slope-intercept form for the line shown? Where's the first thing you're going to look? It's a positive slope. Do I have any negative slopes over here? Yes, so it can't be C. What's the next thing we can look at? The y-intercept is negative 3, right there. Can I eliminate any more? A and B. So I have actually eliminated everything. I didn't even have to figure out what the slope was. I know the answer is D. Okay? So on a problem like this, elimination can be very helpful. I could sit here though and say, okay, my slope is negative 3, and then so I have y equals something x minus 3, and then I have this rise of 1, 2, 3 over 1, so that's 3 over 1. I could do all that, all right, and it really didn't take me that long to do. But the point is, on standardized tests, sometimes you don't want to go through the exact process we learned in class. Sometimes you want to try to go as quickly as you can to see that there must be this answer, even though I didn't really calculate the slope. Okay, so now that we know slope-intercept form, and we know how to work with slope-intercept form, we know that if I know the slope and I know the y-intercept, I can write the equation. And we know how to calculate slope. And if I had a graph, we could see the y-intercept. But there's more that we can do with that. So sometimes you will be given two ordered pairs. If I give you two ordered pairs, you can figure out what the equation of that line must be. We did this in the lab the other day. Okay? I gave you this ordered pair. I said it's going to go through this point, and I want it to go through this point over here as well. And you did that. We can do that without a graph, though, too. We can use algebra to find out the equation for that line. So, this is how you do it. Here's your steps sitting over here. The first thing you want to do is find the slope between the 2 points you're given. So if I give you these two ordered pairs right here, we know how to find the slope. How do we find the slope? Good. M equals y2 minus y1 over x2 minus x1. We're going to use that. All right? They give us these two ordered pairs, but we're smarter than that. We can use the slope equation to come up with the slope. As soon as we have the slope, we can plug the slope into y equals mx plus b. So this number that we get right here is now going to be sitting right here. Then once we do that, you can pick one of the 2 points that you're given. It doesn't matter which point you pick. Pick one of them. Whichever one looks like it has easier numbers is my advice. Okay? Plug it in for x and y. So you know, like, that's an x, that's a y. That's an x, that's a y. So whichever point you pick, plug that one in for y, plug that one in for x. Or, plug that one in for x, plug that one in for y. Or plug that one in for x, plug that one in for y. Okay? Once you do that, you'll be left with, you'll have a number here times a number here, plus b. Solve for b. And what does that give you? The y-intercept. So now you know the slope and you know the y-intercept, so then you'd be able to write the equation. Y equals whatever your slope was, x plus whatever your y-intercept is. Okay? It's like a three-step process, and it seems like a lot of work right here, but once you see a couple of these problems and do some practice problems on the homework, I think you'll find that it's really not that difficult. They are kind of longer problems, though. Definitely longer than like 2 plus 2. So let's see if we can do this for this example right here. I give you these two ordered pairs. I want to know the equation. The first thing we need to do is plug the two ordered pairs in here. So if we're still at the point where we don't know, or we can't remember as we go through, then I'm going to label here. This is x1, y1, x2, y2. If you're past that point, that's wonderful. Don't have to write it down. Okay, m equals what? That is negative 8 minus 1 divided by 5 minus 2. Simplify that down. Well, it's negative 8 minus 1. Negative 9 divided by 3. And now what? Reduce. Does this reduce? Yes, we get negative 3. So we know our slope is negative 3. Which means in my slope-intercept form, y equals mx plus b, I now know what that m is. So I can write my equation. Y equals negative 3x. I don't know b yet, so I have to write plus b. So now my job is to find b. I do that by, number 3, picking one point that you're given and plug it in for x and y. So my advice was to pick the easier one, whichever one has easier looking numbers. Which one looks like it has easier numbers? Okay, so 2, 1 looks a little bit easier. So we're going to plug these numbers in for x and y. So what will I write? 1 equals negative 3 times 2 plus b. Now what do we do? Just solve for b, yeah. So this becomes 1 equals negative 3 times 2, which is negative 6 plus b. Look at that. My b's and my 6's look the same. And we're solving for b, so I'm going to... This is negative 6. To get it to go away, I've got to add 6 to both sides. And that gives me 7 equals b. So now I know what b is, and I know what m is, which means I can write my equation. Y equals the slope that I found, negative 3x, the y-intercept that I found, which was positive 7, so plus 7. And that is the equation. All right, so there's my equation, negative 3x plus 7. And what were the two ordered pairs that they gave me? 2, 1. 2, 1 is right there. Let me mark it. Right there. And what was the other point that they gave me? 5, negative 1, 2, 3, 4, 5, 6, 7. Sure seems like my line goes through 5, negative 8 as well. Okay. What's the y-intercept on this graph? 7, all the way up here, like we saw in our equation. And what's the slope of this graph? Down 1, 2, 3, right 1. Down 1, 2, 3, right 1. Okay? So we see that the equation did graph, or this is the equation that we made right here. Okay? We see that equation, and we also went through the two ordered pairs that we gave. So I just wanted to check to make sure that the math that we did to create that equation actually does create a line that goes through the 2 points that they gave us. Okay? It works. It always works. So follow that procedure, and you're going to be just fine. We have 2 more examples here. I'd like you to try the first one only. So where do I start on this first problem? What do I do first? Okay, so what is that? What are you trying to do first? Find the slope. So we want to find the slope of the line that goes through these 2 points first. M equals negative 3 minus negative 2 over 1 minus 3 equals. Well, I got minus minus here, so I'll change that to plus plus. And I have negative 3 minus, or plus 2, which is negative 1 divided by negative 2. Does that reduce? The numbers don't, but the signs do. Negative 1 divided by negative 2 is positive 1/2. Now that I have that, what do I do? Write your equation, y equals, okay? So what did I tell you to do next? Plug in either one, whichever one looks easiest. Doesn't matter which one you pick. So which one of these two looks easiest to you? All right, first one I heard was this one right here. So that's the one I'll pick. It's okay. What do I write? Negative 2 equals, so 1/2 of 3 plus b. And now we just solve for b. So we have negative 2 equals 3/2 plus b. We don't multiply. What do we need to do? Subtract. This is its own thing. I got to get rid of it. So this is a positive 3 halves. I turn it into 0 to make it disappear by subtracting 3 halves from both sides. Subtract 3 halves from both sides. Two minus 3 halves. Maybe you reached for your calculator, maybe you found a common denominator. Either way, what did you get? Negative. Negative 7 halves. Negative 2 turns into negative 4 halves. Negative 4 halves minus 3 halves is negative 7 halves. Okay? Make a common denominator. Or grab your calculator. Type in negative 2 minus 3 halves. You'll get negative 7 halves. Equals B. So now my equation is there you go. So a little bit of fraction work in there, not too terrible. Just because you see fractions doesn't mean you're doing it wrong. Keep going. Get it done. All right, the second one here, let's talk our way through that one. What do we do first? M equals 10 minus 6 over negative 3 minus 1. Okay, simplify that down. What's the top? 4 over negative 4, so that becomes negative 1. So I'm going to write equals negative. I could write the 1, x plus b. Now what? Either point. We have y equals negative 1x plus b. This one looks like it's the easiest point, so I'm going to plug in what? 6 equals negative 1 times 1 plus b. So this is 6 equals negative 1 plus b. So to get rid of this guy, I got to add 1 to both sides, and I get 7 equals b. So therefore my equation is negative 1x, but I don't have to write the 1. I could just write negative x plus 7. If you wrote the 1, that's fine. So now that we know how to do that, go to story problem land. And it says in 1997, about 2.6 million girls were involved in high school sports. That's probably nationwide. The number of girls in the sports has increased at a rate of 0.06 million per year since 1997. Is that a lot? How many is that? Like, give me an actual number, not 0.06 million. Very good. Yeah, it's 60,000. Is that a lot?
Yeah. For Grable, yeah.
Well, yeah.
No.
That's like 50 Grables. Actually, it's way more than that if you're just talking about girls. Right? So 60,000 per year, that's quite a bit. Since 1997. Write an equation to find the number of girls in sports since 1997. Graph the equation, then estimate the number of girls playing high school sports in 2017. So there's 3 things we have to do here. We have to write an equation, we have to graph the equation, and then estimate the number of girls. Okay? 3 things. In order to start, we have to write the equation. So how am I going to write the equation? The answer is, first of all, starting right here, since 1997. Because they said since 1997, I can say that time starts when? In 1997, okay? So therefore, if I have a graph, and time started in 1997, where is 1997 on this graph? Right there, okay? Time is 0. here. So in 1997, if I knew how many girls there were in sports, then I'd be able to go up to that number, and that number would be my what? Y-intercept, that's right. So, do I know how many girls were playing sports in 1997? 2.6 million girls were involved in high school sports in 1997. That's my Y-intercept. Okay? So already I have Y equals mx plus 2.6 million. Now I just got to try to figure out where my slope is at. It says the number of girls in sports has increased at a rate of 0.06 million per year. Per year. That's a rate. It even said rate. And what is slope? What's another phrase for slope? Rate of change. They gave me the rate of change, which means they gave me the slope. Okay? So even though it doesn't say slope in this problem, because I know that slope is a rate of change, and they told me rate right here, I know that that is my slope. So that means that my equation is y equals, now it said increased, so am I going up or am I going down by 0.06 per year? I'm going up, which means I need a positive or negative slope? Positive. 0.06x plus 2.6. There's the equation. There was a lot of thinking to do in that problem. No math at all. Okay, write an equation. Done. Graph the equation. All right, that's going to kind of be a little bit trickier. Well, how are we going to graph this? Can we have negative girls? Can we have negative time? Okay. Origin down here. So let's put our axes here. That's always a good place to start. It kind of gets you going, and then maybe it'll help you think of other stuff. What has to happen next? Labels. So which one goes on the x-axis? Time or girls? Time. And time in this case is years. So that means number of girls goes on the y-axis. What's next? Scale. So let's think about this. We have, technically this is 1997 when we started, but we're calling that year 0. So this is 0 right here. I have 14 lines. How far do I need to go? It says estimate in 2017, but do I need to go that far? No, I don't. I just need to go far enough so that I can see this line, okay? So could I go by ones? Sure. Go by 1. 1, 2, 3, 4, here's year 5. 1, 2, 3, 4, here's year 10, and then 14 there. So how far does that take me? What year would that be in year 14? No. Yeah, it takes 3 years since 1997 to get to 2000. So 11 years after that would be 14 years since 1997. So that would be 2011. Okay? Good one. All right, so there's my scale there. I got to come up with some sort of scale here as well. By ones? By 1 millions? I can go by ones, I can go by halves, I can go by whatever I want to go by. But if I go by ones, I got to remember that I'm not really going by ones, I'm actually going by 1 million. Okay? I just won't write all those zeros down if I go by ones. Huh? That is a lot of zeros. Too many zeros. Too lazy for that. So I'm going to go by 1 here anyway. But it's actually by 1 million. So in parentheses here, I'm going to put millions. That gives me a little bit added scale, and then I don't have to write all the zeros all the time. So 1 million, 2, 3, 4, here's 5, 6, 7, 8, 9, here's 10. And then 14 at the top. We won't get that far though. Okay, we're ready to graph. Y-intercept is 2.6. 1, 2, and then 0.6 is probably like right there. Okay, now how do I graph the rest? We're going up by not 2.6, 0.6, and then over how far? Over by 1. Oh, we're going up by 0.06, that's right. So maybe my scale here is a terrible idea, because 0.06 is pretty small. Half a million? 0.5 million? A tenth of a million? 100,000. It's tough. It's a tough one to graph. So we're going up by 60,000 each time, which is just less than 1/10. Okay? So we're only going to rise by a very tiny amount each time. So I'm going to go up like 1 pixel on my graph each time based on my scale here. I'm very carefully trying to go up by 1 pixel each time. Okay? Very slowly rising. An easier thing to do here is going to be to say, how many girls have we added in 10 years? So 10 years down the road, it would have been 60,000 girls times 10, 600,000 girls. Okay? That's like the entire state of Wyoming. So 600,000 girls higher than we were right here. Instead of 2.6, we'd be at 3.2 at year 10. So I'm going to go to 3.2, which is like there, and then all the way over to year 10 gives me a dot that I can easily put down, and now I can easily make that graph. I don't have to try to guess a bunch of stuff here, okay? Because I have this dot all the way over here, which is going to be good enough. So now I can draw using these 2 dots that I just put down, the y-intercept and that last dot that I put down, and you can see that my dots were already slightly off, but I did a pretty decent job. Yeah, going up by 1 pixel is pretty inaccurate for sure. Each pixel is 10,000 girls. All right, so we made the graph, and the graph is never going to be really accurate, but we got to do the best job that we possibly can. Now estimate the number of girls playing high school sports in 2017. Well, I kind of did that already when I did this dot right here, sort of in my head when I multiplied by 10 and then added on that 2.6. We're going to do the exact same thing. We just have to figure out how many years since 1997 is 2017. 20 years. So what do I need to do with my equation? Plug in 20 for x, that's right. So y equals 0.06 times 20 plus 2.6. Be careful when you do problems like this. A lot of times people will make a mistake and they'll plug in 2017 here when they called year 1997 year 0. So you got to be careful. Make sure that you keep in the same units. We're since 1997. This is 20 years since 1997 right here. So we get y equals, and you're going to want to reach for a calculator here, 0.06 times 20. $1.2 plus 2.6, so y equals 3.8 what? Million frogs. Girls. I don't know. That sounds like a lot of girls. Too many girls. Yep. But the point is, how many girls are now playing sports in 2017? 3.8 million, up from 2.6 million. That's a good thing. So instead of Nationwide Girls, our band is going to sell some donuts for $5 a bag. They spent $200 on all of the bags of donuts they bought for the sale. So, question, how many bags did they buy? Or, yeah. Do we know? We don't know. Does it matter? Does it matter how many they bought? No. All that matters is how much they spent. They could have bought 72,000 bags of donuts. It doesn't matter. They spent $200. Okay? So we don't care how much they bought. All we care about is how much they spent. They spent $200 on all the donuts they bought for the sale. So how much would they like to make back? At least $200. Otherwise, it was a waste of time, right? A waste of money. And then they got all these donuts. Okay, write an equation for the profit P made on n bags of donuts. And I want to use slope intercept form for this. Profit is how much money you make, right? So if you have a negative profit, what does that mean? It means you lost money. You spent more money than you made back, okay? So if they spent $200 right off the bat, what am I going to call that? Negative 200. And what is that negative 200? It's the y-intercept. So we're going to use slope intercept form. Y equals mx plus b. Now I'm going to use the variables that they gave me. What is going to go in for y? P. The profit equals m. What's going to go in for x? The number of bags, so the slope times the number of bags plus the y-intercept. So we have P equals, we already know that the y-intercept, the amount that they spent, is going to be minus 200. Then we're going to have something else here. This has to be money, because this is money. We have to have money minus money. So what needs to go in for M? $5. Why is it $5?
Because they sell it for $5 a bag.
Yeah, notice it says $5 a bag. That's like $5 per bag. That's like $5 each bag. And I've told you over and over that anytime you have the word for, or each, or per, or for every, or even in this case, that usually gives away that that number is attached to the variable. And sure enough, we're going to put the 5 on the variable. Okay, $5 per bag. So if I want to know how much money I made, I'd take $5 times the number of bags that I sold. So this makes sense. I got to subtract off the amount of money I spent in order to get the total profit. So this whole equation hopefully makes sense to you guys. All right, it says write an equation for the total profit P made on n bags of donuts. We did. Graph the equation. Okay, we need to do that. Then find the total profit if the band sells 150 bags of donuts. That's a lot of donuts. But let's worry about that later. Graph it first. 150 donuts is a good thing.
150
Bags of donuts. Yeah,
I did that for
for sure. Until they went moldy. Let's graph it. What are we going to do? Can we have negative donuts?
Yeah.
No. Can't have negative donuts. Can we have negative money?
Yeah.
Yes, we can. So this one's a little tricky. Normally we've been putting our axes down in the lower left-hand corner. We can't do that here because we have a negative y-intercept. So we are going to put, because we can't have negative donuts, we are going to put our y-axis there. But I'm going to put my x-axis dead center. We can do that. So what goes on the x-axis? How many bags of donuts? So this is bags, and this is profit. The more bags I sell, the more money I make. That's why bags has to go on the x-axis. So now we're going to graph this thing. We need to come up with some sort of scale. I got to get all the way to negative 200 on my y-axis somehow. So I have 7 lines sitting here. Got to get to 200 by 20s. If I did that, that'd be 20, 40, 60, 80, 100, 20, 40. 25, 50, 75, 100, 25, 50, 75. 50s? 50, 100, 50, 200. Does that work? Okay. Now the tough thing though is I'm going by 50s and I have a slope of 5. So it's going to be tough to draw that. So we're not going to be able to go rise over run, up and over. We're going to have to pick a point somewhere along the way. All right? So if we go by 50s, that's fine. We're going to go by 1s probably here. There's 100. There's 200. That's negative 100 and negative 200. Here's positive 100 and positive 200. We're ready to graph. So we have the y-intercept of negative 200. And then I need to pick something that's going to give me another ordered pair so that I can graph this easily. I'm just going to go over here somewhere, like 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's go with 10 bags. If the band sells 10 bags, then that would be 5 times 10, which is 50. Now 50 minus 200 gives me negative 150. Negative 150 is right there. So all the way over at 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I got to go down still to negative 150. And I can put a dot there. Notice that that's not much change. Because of the scale that I have, everything is very squished and seems very flat. So you need to be careful about the scales that you make. Maybe by 50s is kind of too squished to make a good graph. But we did the best we could with these 2 dots. So we can draw that line in there now. And that line would continue rising for forever. Okay, write an equation, we did. Graph the equation, we did. Find the total profit if the band sells 150 bags. Before I do that, let me ask you this. Will this line ever go back to 0 here? Will they ever make a profit? Yes. Eventually, they will sell enough bags to make a profit. Okay? So down the road, I could ask you something like, how many bags do they have to sell in order to break even? And then after that, they start making money. But I'm not asking you that here. I'm asking you find the total profit if the band sells 150 bags. So what are we going to do? Plug the 150 in right there. So P equals 5 times 150 minus 200. So P equals 750 minus 200. So P equals $550. So I got to make my label on there, and there you go. If the band sells 150 bags of donuts, they'd make $550 profit.